Okay, so now we're doing 10.3, which is graphing cube root functions. So this is no longer the dolphin jumping out of the water because there's a little 3 in there. This one actually ends up looking like a sideways S. So notice my table of values is different. It's not -2, -1, 0, 1, 2. That's just because I'm picking perfect cubes so that this plugs in easily. So the cube root of -8 is -2. The cube root of -1 is -1. Cube root of 0 is 0, 1, and +2. Okay, if you want to keep that pattern going, you can. So let's take a look at it. So I go -8, -2, -1, -1, 0, 0, that, and that. So those are all the points right there. So I just want to point out to you guys that we're back to 5 points. Dolphin jumping out of the water is the only one that we are fortunate enough to only have to graph 3 points. So this graph looks like this. Okay, so that is a cube root graph. Because I can equal any x value or any y value, the domain is from -infinity to infinity, and so is the range. So -infinity to infinity, or all real numbers is another way of saying that. So I'm going to write that here. All real numbers, all real numbers. That's what that says. There's square root graphs do not have a domain of all real numbers, the one that we did before, because they can't be negative. So that has a different domain, but we'll get into that later. Okay, so let's go ahead, just like anything we've been doing, we're just going to go through real quick. This one's going to go down 4 because the 4 is not in with the x, neither is that 3, so up 3. X minus 1 equals 0, x equals 1, so we're going right 1. This one, x plus 1 equals 0, x equals -1, left 1. Okay, you can't see that, but now you can. And then for this one, we got a horizontal and a vertical, so we are going to be going, let's see, what is that one? Sorry. We're going to be doing x minus 2 equals 0, x equals 2, so I'm going right 2, down 2. And then this one, left 3, up 1, right? You guys are getting the pattern. I'm always going to do the work because when we do y-axis transformations, we need to be really careful. So I always just set it equal to 0. Everything that's underneath gets set equal to 0. So I'm not setting the 1 because it's not equal to 0. Okay, so there's that. And then the next thing we got to do is actually do those transformations we just saw. So you have your 5 points, guys. It's the same 5 points. Let's see, 4, 8. Perfect. So there's the 5 points. So we have the diagonal 3 right next to each other, and then we got to go out 8 and up 2 from 0, 0 for that. So now I'm just going to move everything down 4. So we go 1, 2, 3, 4, and put a point. Move every point down 4. And then we have our graph. So it kind of curves like that. It doesn't kind of, it actually does. I don't know why I said kind of. Anywho. Okay, next one we're going up 3, so I have my parent points. Homework should be like so easy for you guys with these graphs by now. If it's not, let me know and we'll try and find a different way to get you clear on this. Okay? Alright. There's that one. Easy peasy lemon squeezy. Now we are doing our horizontal ones. So there's the same 5 parent points. And I'm going to be going right 1. So every point moves right 1. I like to start with my center point. I call it my locator point just because it keeps me centered. That was not a funny joke, but it kind of was. So there's that. Right 1. Okay. Now I'm going to go left 1. So we're just giving you, if you're like, why are we doing so many examples? We're trying to give you every possible scenario that you could come across. So we did an up one, a down one, a left one, a right one, so that when you're doing your homework, if there's one that's giving you trouble, you can refer back to your notes. So you definitely should have your notes out when you're doing your homework. Okay, now we have 2 transformations, right 2, down 2. Yay! We love math. Okay, let's do, my hardest choice today is picking the pen color I want to use. Right 2, down 2. There's my center, and then that, and then right 2, down 2. So, ooh, on the x-axis. Okay, there we go. And then our last one that we have in this column is left 3, up 1. So you notice we haven't done any transformations and we haven't done any stretching or shrinking. So that's probably what we're going to be doing next. Okay, guys? But we can handle that because we've been doing this for a while now. Left 3, up 1. There's my center point. I know the pattern. And then I just go to these other guys and kind of 1, 2, 3. Even if it's off the graph, we're still going to graph it. Alrighty. So there's that. So now let's go ahead and take a look at the next thing. Oh, look. We are going to be going over what we just talked about. If there's a negative in front, we reflect over the x-axis. If it's in with the x, like that right there, we're going to shift. One quick thing that I want you to do real quick is I want you to put little 3s up in there, because these are cubic graphs. So put your 3 up there so that we're clear that we're not doing the dolphin graph. And then the number out front, or not in with the x, off to the side here goes up or down. So I think we're just adding in some reflections right now so that we're clear. Sometimes students have a hard time reflecting these, so we like to make that its own separate example. So this is reflect over x-axis. We're not doing the y one right now. This one, I'm going to reflect over the x-axis. And then I'm going to go down 2 because it's not in with the x. This one, I have reflect over the x-axis. And then this one, I have x minus 3 equals 0. When I add 3, it means I'm going to actually go right 3, even though there's a minus, because horizontals are backward. And then reflect over x-axis. Ooh, and then I have x plus 2 equals 0. Subtract 2, so I'm going to go left 2 and down 1. Okay, so we're taking the same point. So your hardest challenge is going to be like, what points do I start with for these? And if you ever forget, you just kind of try and make a table. Like, it's super easy. Or if you can figure out how to do it in the calculator, then you can maybe check that way too. And if you are allowed to use a calculator on your test, I'm probably not going to show you how to do it with a calculator, but maybe you're technically savvy and you can watch a YouTube video on it. It's not going to be mine, so it's not going to be cool, but whatevs. Oh gosh, I think I need sleep. Just trying to keep you guys entertained. So this time I decided to just plot all my points so that they're there, because I already know the pattern. So now I'm going to reflect. So with this reflection, remember, I'm going to start from left to right. This is 2 units away, so then it's going to go 2 units away here. So it was a negative point, and now it's a positive point. This one was 1 unit away, so it's going to be 1 unit away. This one is on the x-axis, so it's still going to be there. This one was positive, it goes negative. This one is positive, it goes negative. So whenever you're graphing these, you always take care of your reflections first. In this particular problem, all we had was a reflection, so we're done there. But in the future, you might have more. So just know you always take care of your reflection first. So I'm going to do that reflection again because I have a reflection. That stays like that. Again, if you want, you can go back through and cross out all those blue points. That's why I use different colors, because then I can just shift really easily. But now I have to take all my pink points and move them down too. So I'll even grab a different color at that point to make sure that I'm still clear on which ones. So I need to move everything down too. Down 2, 1, 2. It's okay if it went on an old point. 1, 2. And there's that graph moved down too. Okay? Moving right along, we have this guy right here. Same thing, reflect over the x-axis. So, excuse me. I'm reflecting over the x in all these points, following my color pattern in my pens, but it doesn't seem to be working very well because this is black and that's blue, and I might get confused, but I doubt it, so we'll just keep moving on. So now I move all these points right through. Okay, so there's that one. And then the next one that I have, oh, we got 3 things we got to do. So I'm going to start with my reflection. So here it is. These are my orange points. There's the reflection. Then I got to go left 2 and down 1. So left 2, down 1. Left 2, down 1. Left 2, down 1. I know it's going to make that pattern right there. Left 2, down 1. Okay. Alright, so we've done all that graphing, so let's just finish this lesson up. It looks like we got to write a couple of equations. So right here, that's a cube root graph. You can see the pattern. Ours are as beautiful as this one because we did not do computer generated graphics, but we can see it. This one went up 2, so we know this is the shape of a cube root graph and it went up 2. Okay, so go ahead and flip it over. Let's do that again, and then we got that stretching and shrinking again too. Okay, write the equation for the given graph. Okay, cube root graph, and we went right 4. So we know it's horizontal, it's in with the x, so we're going to make a bigger cube root, and we're going to go x minus 4, because then if we set that equal to 0, we'll get our right 4 shift. Okay, let's keep going. This x minus 12 is going to be, it's in with the x, so I'm going to be going right 12. It's a horizontal, and I know this because if I set it equal to 0, I get positive 12, and positive 12 is to the right. Okay, this one, x minus 4 equals 0. So sometimes students get things backwards when they see it like this. It's really simple. If it's in with the x, it's going horizontal just like x's go. And I'm going right, and then this one I'm going to go up 8. Okay, so now we're ready to move on to the transformations. We just did this, the transformations with stretching and shifting. So it's the same thing. If it's out in front, like this, if there's a number out in front, then it is a vertical stretch or shift. And if it is inside, it's a horizontal one. If it's outside, you multiply the y values. So I'm putting multiply the y values here on this part because up here you're going to multiply your x values, but you need to make sure that you realize it's not multiplying by 1 over b, it's the reciprocal, because we do the opposite when it's horizontal. We do not have to do the opposite when it's vertical. Okay, so this one right here, let's see, this is going to be 1/2, so that's vertical because it's out in front, and when it's vertical I just get to copy that number down, so it's the fraction of 1/2. And then I'm going to the plus 5, may not be the order of the question, you can go whatever order you want, but I like to go in the order of the equation. So I'm going left 5, and then there's that other vertical one, which means up 11. Okay? Moving on, next one. I feel like you guys are going to be so awesome at this. I see a negative, so that's going to be reflecting across the x-axis. Anytime it's out in front, it reflects over the x, okay? And then the next thing I see is a 6 out in front, so that's a vertical stretch multiplied by a factor of 6. Then I have this horizontal business of going left 3, and then I'm going down 9. Okay, moving right along. Sorry, I'm going to give you just a second to copy that down. I guess you could always press pause. Alright, I'm moving on. So now we're doing the horizontal stuff. We've already went over it, so I'm just going to get right to it. So I see a 5. It's under the cube root. It's right next to the x, so that's a horizontal. And instead of multiplying by 5, because it's horizontal, I have to do the reciprocal, so that's 1/5. Because I'm multiplying by a fraction, it's a compression. And then the x minus 1 equals 0, x equals 1, that means I'm going right 1. Okay? And then second to last problem here, I see the 1/6, that's going to be horizontal by a scale of the reciprocal of that, so just flip it, 6. X plus 2 equals 0, x equals negative 2, so I'm going left 2 and down 12. Okay, so then the next thing we're going to do is we're going to write the equation of this one, which this one has a stretch. You can tell, look at this one, I know this one. Oh guys, did we forget a negative here? Do you see this? Wow, I'm glad we did this. I looked at that way too quickly. So I'm going to flip it over real quick just so we can see. This graph goes, this is the parent graph, it starts low and then crosses 0, 0 and goes high. But if you look over here, this one's actually starting high and going low. So no problem, we'll just add our negative in it. But remember our points for these graphs were like this right here. They were these 5 points. Okay, so now we're going to go back to the problem I actually wanted to do, but the whole point of even showing you this problem is, can you tell that this graph is the parent graph versus this graph? Can you see the stretching there? So this is a vertical stretch, and if you want to know the point, we know this is like the center point, and normally it's up 1 over 1, which would be, here's negative 1, here is where our next point would be, here is where another point would be. So if it wasn't stretched, this is what the graph would look like. So if I just shifted it and I didn't stretch it, this is what the graph would look like. So what I want to pay attention to is this point and this point. So originally it was at 1, like right here, but now it's up here. So that distance has doubled. So that's going to be stretched vertically by 2. And then you can see we're not at 0, 0, and we went left 2. Okay, so I'm just going to go back to that stretch again. Here's another point. Here, this distance from the parent graph is 4, but now 4 to 4 equals 8, so it's doubled. So I should say 4 plus 4, I'll just write that. So it's doubled, so that's being stretched vertically by a factor of 2. So this is 2 times the cube root. It's going left 2, so that's going to be x plus 2. Alrighty, and that's it.